Okay, we are going to try to get this Arduino Portenta with LoRa antenna and the LoRa Vision Shield. It's also got microphones, SD card, whatever. We are going to try to get it connected with Helium and then send some data to Adafruit. So, this is the Maker 100 course. If you go right down, this is almost the last thing we do. Right here, Helium, we're going to load up a program called dot335. It is in my Portenta Pro Community Solutions, which is an Arduino IDE library you can install. Just search for community. It should be one of the first ones. And so for getting it on the Arduino, it is going to, here's the dot335 program. If you've got Portenta Pro Community Solutions, it is just in the Vision Shield section, in the LoRaWan section. It's the last one. We're doing HTTP to Adafruit. There is easier Cayenne to Adafruit, but it's less flexible. So that's what I've got loaded here. Now, every once in a while, if you've been messing around with your LoRa Vision Shield, you might need to go to this MKRWAN example MKRWAN. Where'd it go? I've got a couple of libraries here. Ooh, can't find it. Anyone see it? It's capital letters. There it goes. MKRWAN. And it's this one. Update standalone. Because if you've been messing with your LoRa Shield, you need to run this. By the way, make sure you're on the Portenta, the M7 core. That's the outer core. Make sure it's just that. And then we've got to get this. We got to be on the right port. So let's just double check that. I think now it's compiling. There we go. I'm going to pause. Okay, so this is the bootloader's going. It's about to install it. There it goes. It's installing. So the Portenta Flash is a little bit different. And now, remember, we're doing the MKRWAN update. We're going to have to check the port. There we go. And go to the serial monitor. And this is just making sure that everything is set up properly. It's erasing the old stuff. If you mess around with any LoRa instead of LoRaWan, you may have to do this before running the main bit of code. Just like the Wi-Fi updater. If you've ever been messing around with stuff, you should go in and re-update the Wi-Fi. Unlike the MKRWAN one, the Wi-Fi updater, if you have to do it, is just part of the Portenta code. That looks like it's done. So now I'm done with that. Here's the dot335 program. And the very first thing you should do is put this back into bootloader mode. Find the right port and just load it up because it has some number built in. Let's just see if everything's good. Load this code up. It has numbers built in. What is it? It's the device EUI that we need to know. Now, eventually, we are going to switch over to the Helium console into devices, and we're going to enter a new device. And also Adafruit, fresh login here to Adafruit, and we're going to go to feeds, and we're going to have to deal with feeds. Let's see how this is doing. Okay, it's still going. I'm going to pause. Okay, this is almost done. There's some information there. There's where you needed the MKRWAN library. If you haven't installed it, you would have to install that. Hopefully I'll go through this later. It is reasonably advanced coding. Okay, looks like that's installed. Now, we need to figure out the port. We need to go to the serial monitor. And if you're too slow doing this, you see I almost was too slow. That's the number we need. And I'm just going to switch over here. Let's make sure that number's there. And let's try to load our pages up again. So what we've got going on here is it's trying to connect, but it can't connect because it doesn't have the extra two fancy numbers. So let's go to Helium. Let's go to devices, all devices. Add a new label, add a new device. There is down here where I'm in the way a little button for adding devices. So let's give it a name, Portenta. I think mine's labeled with a 5. Now, it gives us a device EUI, totally confusing. We need to paste that one that's built into the Portenta. Okay, that's super important. It also gives us an app EUI. We need to copy that and switch it over to here. See, app EUI. So I'm going to paste that right there. Now it also has an app key, which strangely was visible. I don't see a way to copy this, so I'm just going to go copy it. And that's the super long one here. Okay. Don't use my numbers. It will generate the new numbers. If you had my Portenta, that number is kind of fixed for it. I have lots of Portenta vision shields, so it's not really a big deal. Profiles we don't need. Attach a label. We don't even need that. Don't need those. So what I'm doing is I'm saving that device, and then I am recompiling this with this new information, not hard-coded, but software-coded in. So you've got the device EUI that's kind of hard-coded into the device. Using some other types of software, you can change that. And then you have these from Helium. You got to grab these from Helium. Rest of the code I'm not that interested in at the moment. It's going to take us a while to do a couple of these things. So I'm going to pause for a bit. While that's compiling, I might as well look at some of this code. I've got a 30-second time interval. Probably should change that to 60 seconds. 5-second delay for getting uploads from the Helium console. While we're doing this, that thing looks like it's running. Here's what it typically says. Wait 2, wait. It gives you 15 seconds, I think, is the code. Oh, no, it's not 15 seconds, but 9 seconds. So it's giving us that number again. Let's just double check. And then it's trying to connect. Ooh, problem here. I'm going to have to pause for like 10 minutes while this device is pending. So I will go. Actually, I'm going to go talk about the code. So your code has your typical includes at the top. Then it has your variables. Okay, I've got a connected variable, wait for downlink. As I said, these are the important ones, and I probably should make these almost double. Make that maybe 10 seconds waiting, and make that, this is 30 milliseconds, so make that 60. But I'm speeding it up so we have a bit more data. This stuff you could throw into a secrets folder. It is better. But here I like to keep things as one file. This is just starting things. There's the serial, the monitor that's right here. Here we're setting some pins, R, G, and B. The onboard LED that right now is blue, we're setting them to output. Here we are setting them. Strangely, onboard LEDs, high means off, low means on, which is totally reversed, and it's to do with it being grounded, not it actually being given 3.3 and you're setting the ground, but I don't want to get into that. I don't like the wall serial because with the LoRaWan devices, you're often putting them on batteries, and the wall serial is going to hold you there and not let anything occur. So I do these 3 sets of 3-second wait just to give you some time to plug in the serial monitor. What else here? Notice I've got US915. Other parts of the world, there are different numbers there. And then it's printing out, that's what it's done here. It's printing out those versions. And then it's enabling the channel for Helium is channel 1. And then there's the main loop. So while you're connected, set the board to a green-blue color, which I think is what it's at. Let's just see, it's still trying to connect. Then it joins, waits 5 minutes, changes the color, waits 5 minutes, 5 seconds, changes the color, waits a second. Now, if it ends up waiting for a downlink, it does some downlink kind of stuff. And here it's just going to write it to the screen. Here it's setting the colors different. Here it's waiting for that milliseconds to happen, so you're not putting in a delay, which is freezing your program. Here it's reading AO. AO would be about there on the Portenta. It's reading whatever value is there. It's changing it into base64. Actually, this isn't. I think LoRaWan will just send it as base64. So, not really sure what that's doing, but it's basically sending whatever value is coming from analog read. It's prepping the packets. It's if there's no error, it says it's sent correctly. If there is an error, it tells you there's an error. And that's about it. Notice I'm not using delay 30 because this is using the timers, which is a little bit better if you're needing to use it in part of another program. So we are trying to connect. I might put this device in a better location because we're still waiting for that to pin, so I'm going to pause for a bit. Okay, so while we're waiting for this to be activated, and what I've done is I've unplugged the Portenta and put it closer to a window. It's sending out electromagnetic waves, very, very faint. So the nearer you can get it to a window or a wall that has nothing metal inside it, the better. So let's go off to Adafruit and talk a little bit about Adafruit. Adafruit, if I was doing an MQTT connection, I would have to go to the My Key and write down the username and this active key. Now that active key is quite important. It allows connection with any of your Adafruit devices. So what we're going to do is something different. This is an HTTP connection, like a web-based connection. And I'm going to go to feeds and make a new feed and just call it LED1. And don't need anything else in there. And so there's my feed. And when I go into LED1, down the sides here, I've got feed info, privacy. So you can make this public so you can view it on a web page. But the important one is this webhook. So we're going to go into webhooks and don't click that, don't click that. It looks like you're supposed to click one of them, but all you have to do is hit create. It wants to know when it expires. I'm going to say after 30 days. I'm going to bump this up just because we're testing. So 20 bits of data a minute. And this is the important thing. So I'm going to copy that so that I can access that. Now I could come back there, but we might as well put it on my little notepad here. And what's interesting here is that's the whole thing. I can't remember if I want that, but we're probably going to only want a little bit of it. So let's get back in here. Get back there. I think I've done everything I need here. I don't need to create another one. We can always go back into webhooks to look at that again. Our data should eventually come through here. So we're all set up with Adafruit. Helium, oh, it's working. So now, what have we done? We have put code onto the Portenta. We have grabbed device information from the Portenta, this one and these two. Okay. You can copy those. This one we got from the Portenta. And so we're good to go. If we come here, where's the debug window? I'm going to scoot this up. There's debug. You want to hit that because that's going to tell you when data starts coming through. I'm only sending data every 30 seconds, so we might have to wait a little bit. Now, oh, perfect. Join request is different than an upload. So join request is probably always going to show up as red. Red isn't necessarily good, but 30 seconds from now or sooner, it should do an uplink. So now we need to start looking at integrations. So while that's thinking, oh, we did, no, that was a second join. So let's go make an integration. So add a new integration. Now notice Adafruit has MQTT set up here. Super easy. It's easier than what we're doing today, but it's not as flexible. So that was an assignment my students would do in a few minutes. What we're actually going to do is set up an HTTP connection and the endpoint URL. That's required. What does that mean? That is, we don't need headers. That is the thing we wrote down over here. But you know what? I think it's the whole thing. If I make a mistake, we will come back and fix it all up. That's my endpoint. Give it a name. HTTP to Adafruit or something. So we're going to add this integration. I'm going to add it right now, and I'm going to go into flows. Just everything looks good at the moment. We're eventually going to come in here and do something advanced. But let's go into flows and hook all this stuff up. Now on my computer, it's hard to see this by nodes. There's a little plus sign right there. And we've got integrations. There's our integration. We've got functions, which we are going to have to make a function. We've got devices. There's our Portenta. So we hook that up. We haven't written a function yet. So let's go in and write a function. I want to not take that. Add a new function. So we're just going to call this my HTTP function. Whatever. It's good to spell it right. The type of function is a decoder, and the format is a custom script. Okay, shows you some examples of custom scripts, but we already have it right here. Function decoder right there. So I'm going to grab that. Good to look at this, what the main one is, but we're going to delete all that, make sure it's all deleted. So it's grabbing bytes of port and an uplink info. It's setting up a decoder. It's grabbing your bytes and changing them into a string. It's setting that into the decoder value. And I'm assuming this is actually doing the decoding. Huh. Well, let's save the thing. You can test it. If I put in something like 4545 there, woo, what did I just do? Somehow I got out of helium. That's not good. Okay, I'm going to pause. Okay, so the script's right there, hiding behind my video and behind the little blurb here is the save function. So we go back into flows. There is our Adafruit. There's our Portenta. We need to connect the two. Now, if you were just doing the regular Adafruit for functions, you could easily find a cayenne function. Now I'm going to connect these together. The information is going to come from the Portenta to Helium. Then it's going to go to my decoder because it's in base64 format. Then it's going to go to Adafruit. Okay, so that's all being saved. 234, that's interesting. Let's go see what's happening with our devices. Lots is happening, but it's still red because it isn't getting decoded, and I've missed one minor little thing. In the integration, okay, HTTP to Adafruit, we have to add something fancier. Show details. The typical default JSON gives a ton of information. We don't want that. So all you do here is put in what you want. Well, we want sent to Adafruit a value, and it's the decoded payload value. And that's what happens so I'm going to save that. Kind of surprised nothing came through on the output. And let's go back and just check our flows. There, Portenta. By the way, if you want to get rid of these things, it's kind of funny. You click, and sometimes, see it says remove edge? Sometimes when you click, you don't actually hit one of the dots. See, sometimes it doesn't hit the dot. I think it's got better, actually. So if you want to get rid of that, you just remove the edge, and you can put it into some other edge. Okay, let's go back to our devices, go back to our Portenta, see if stuff's coming through. We stopped getting any information. So I'm opening up the debug console. There's what's happening. The Portenta is going to the debug, going to that. There we go. We get an uplink, downlink, uplink confirmation, and it's blue. Wow. By the way, there are so many steps where this could mess up. You could program it wrong. You could not be close enough to a Helium access point. By the way, always a good idea to type in Helium coverage map. Find your city, see what your coverage is like. Getting a miner for yourself could take a long time. But if you're in a city, let's say we're in Seattle, the green is coverage. So as you zoom in, you could find your spot and see how well you're covered. Now, 1 is good, but look at these numbers. Like that has 7 receivers in that spot. That has 5. So you would have tons of coverage if you were there. So now, here we go. In our feeds, LED1, we've not got much information, but this is reading the pin AO on my Portenta, which isn't hooked up to anything, so it's just giving random low numbers, 60, 60, 59, 60. Okay, hopefully they're not all 60. And every 30 seconds it should be updating. Here we are. Yeah, 10, 20, 11, 10, 19, 47, and there's our graph. We're doing pretty good. By the way, I don't even really teach this stuff. You could set up a dashboard, welcome dashboard. In your dashboard, you create a new block. I typically do the stream first of all. You just check off your one, create the block, and there's the block. So last step you could do here, edit your layout, and I should be able to just delete these ones if I don't want them. Delete, this is just old blocks. Delete, and we'll grab this block and move it up. And just like that one, always do the stream so you can see what's coming in, but you could add new blocks. You can share this. There are buttons, there are all kinds of stuff. So I think we're doing pretty good. Once again, back to your feeds. LED1 is the feed we've set up, and there's the data coming in. So it's going from the Portenta to Helium. We're sending off from Helium in the flows menu to our decoder to Adafruit. Let's just show you here in the devices. You've got these 3 kind of important bits of information. The first one came from the Portenta. The other 2 come from Helium. In the functions, we have a function with this stuff, which is decoding the base64 information. In integrations, we have an HTTP integration sending the webhook. The nice thing with the webhook, it doesn't have your super secret key for Adafruit. It just has this thing that you could put on web pages. The only extra thing we haven't really talked, and this, in the template, Adafruit is expecting a JSON value with some amount. The way we get that amount, it's been decoded, it's the payload, and we called it value. Okay, so one extra little thing which may or may not work. I don't have the serial monitor hooked up here. It would work. Let's go into my devices, Portenta, and instead of the debug, the downlink. So if I chose to send downlink, and I think I send it as text. So if I sent hello, I don't want a confirmation, and that thing. And so now what's happening, it looked like it got cleared already. The red's not so good, but there, it came out as a blue. So on your serial monitor, if I was hooked up, you would probably, it's not hooked up, you would then see the hello. So you can, from Helium, dump stuff into your Portenta to turn things on or off. I haven't quite figured out how to do that in Adafruit. I don't even think it's possible. Maybe from a web page, some of the other ways that I access stuff, it's possible. Anyway, that is it.